Namaskar, my dear friends. So let's try to understand how we can design any hardware circuit that is there in our hand. So basically, there will be a, let's say, microcontroller card, or we have microcontroller based designs. So you would have seen various applications from various manufacturers, let's say semiconductor devices. So we have some evaluation boards. So what are the parameters that we need to take care of? Or suppose we have a very specific project. So what are the things that we need to have in our hand or have in our like portfolio, so that our design doesn't go wrong at the later stage? As you know, while the brainstorming, or you have the concept exploration and block diagram preparation, so all these things are very much needed essential skills that will make sure your board, which is fabricated and assembled, will definitely run. Okay, so what we'll try to understand here is what are the steps that we need to take so that we can start a board design, and then we can come up with a successful product. So this particular session is going to be very useful for the engineers who are very new or they are freshers, and at the same time those who have not yet started any circuit design for complete board application or complete system applications. They can be very easily able to utilize this particular concepts or particular process to start from a complete like a design life cycle of a product. Okay, so as you can see, for example, let us say we have a design for control card which is having various applications, various peripherals. So this was designed for general purpose board, which is nothing but an evaluation board from STM. So STM is a evaluation board which is having very less number of peripherals. However, what I have designed here is having many parameters that we will look into, like why to do that. Okay. Same way we can see one more circuit which is there from Texas Instruments. So Texas Instrument MSP M0Z3507, MSP M0Z3507. So this is the particular device, particular microcontroller that has been released recently, and it is very rich with all the peripherals and so many specifications. Okay, and this is applicable for your automotive application as well. So however, what are the things that we require that we'll try to understand? So let's start with the things. First of all, let us say we have to design a board with a microcontroller which will be there in the middle. Okay, and we have lot of like peripherals like 1 2 3, so many peripherals are there. So how do we decide all those things, and how do we take care of or keep a track of them so that we do not lose anything at the end of the finished product? Okay, so basically, first of all, we have to have an understanding of microcontroller selection process. Okay, so microcontroller selection process, as you can like, this is a very big topic, very huge topic, so I'm not going to explain much about it right now. However, we have already released a video about it, like how to select a microcontroller based on, let's say, number of pins, or number of like how many IOs we need, or we need UART, I2C, like SPI, ADCs. So all those like specifications or communication interfaces that will be needed. Do we need a PWM controller, or like PWM outputs we require? We need timers, or we need CAN, USB. All those parameters will be listed in a table so that we can populate the parameters of the microcontroller that we are looking into, and that's how we will be selecting a microcontroller. And most of that, we have to select the manufacturer as well, like which manufacturer we are targeting based on the availability of our company capability of software development, as well as very like rich about our skills as well. Okay, so this was the first step, which was selecting your microcontroller if you are going to design a microcontroller based design. Coming back to the ADC circuits, so let us say you have the application where you will be interfacing your ADCs of the microcontroller. So this is my microcontroller, and we have ADC channel, and that is coming to like generate, I mean, measure some of the voltages that is there from the uh, desired outputs. So let us say we have a voltage level, let's say 5 volt, and we have put it R1 R2. So this one directly we can send it to my ADC, so that this is well below my V reference voltage, and then it is going to ADC. However, is it recommended or is it not recommended? So for that, we will be requiring, like one buffer which will make sure that it doesn't go any, like low current or something like that. So basically, our main purpose would be to select an op amp as a buffer, and that will make sure what is the, like ADC channel that will be selecting, and ADC will be giving you the output in the microcontroller. So this is one of the, like required essential skills, how you are going to voltage divide your input voltage or any other parameters. Let us say you have a temperature sensor outputs or pressure sensor outputs or anything. All of them needs to go to ADC channel, and ADC will give you the and give you the value which will be deciding what is the actual analog value that was there. Okay, so for that we need definitely either amplifier or, like op amp as a buffer. So those things will be needed. So you have to have in mind as number two that okay, we are going to select an op amp as a buffer or as an amplifier for our circuit design. So all these lists we will be populating one by one in our notebook or in our Excel sheet or in a Word file or PPT, wherever you feel comfortable. Okay. Coming back to the third part, let us say we need to save data storage, like data storage for live data. So if we are going to store live data, we need some EEPROM. And if our microcontroller is not having EEPROM capability, like EEPROM is nothing but a storage space. It is just like SRAM, flash, all these things. However, EEPROM has the better number of capabilities, and at the same time it has a very high endurance. Okay, so EEPROM is used for live data storage. So basically we have lot of EEPROMs available from STM or Microchip. All right, so we can select any of these two manufacturers, and we can select one EEPROM for our best suitable application. It can be ranging from, let us say, 2 kilobits to, let's say, 32 kilobits or something like that. Okay, so around 2 kilobits, 4 kilobits or 8 kilobits are more than enough EEPROMs for our live data in a small application like NIBPs or temperature sensors or some SpO2 applications. Let us say we have to have a like a temperature sensor as well in our control card. So we can select a temperature sensor for this purpose, whether it can be a PCB mounted or like a, TO92 CAN type, or maybe let's say SC70 type or anything. So we have lot of temperature sensors that we have already released in our video. There also you can have. So what I am telling you is basically, if you are listing out each and every parameters one by one, it will be needed. Okay, so temperature sensor you can select for your design. At the same time, let us say you have to have a high-end temperature sensor requirement for a study application. Let's say you have to have uh, oxygen concentrator application, or maybe the place where you have to put your temperature sensor where there is lot of vibrations or something like that. So there you are not supposed to put ICs. Okay, so in that you will be putting some lug type temperature sensors. Okay, in that case you will be having wires, and this wire will be soldered or maybe put together through a screw type. Okay, so this kind of temperature sensor also you will be selecting a component. So basically your main aim should be to list out all the components that is needed for your complete control card, and then you select each and every components for their required parameters. This will enable you to make sure how to design the circuit very properly and very easily without making any mistakes. Let's say we need some infrared sensors also, like pin photodiode or something like that, or sorry, this is IR sensor, something like that. Okay, so where you have to have IR sensor applications where it will be receiving some IR sensing, and based on that it will be giving you output, so it can be connected to your GPI of your microcontroller. So you need to select for infrared sensors as well. This can be selected from, let us say, for example, I can give you one manufacturer, Visa. Okay, so Visa is one of the best company for infrared sensors, where you can select a various, like broad portfolio of different kind of sensors. Now let's move to list out other parameters. Let us say we have to have a interface of our pressure sensor. So pressure sensor, you find out a component which will be utilized for your pressure sensor application. It can vary from your let us say 4 kilopascal to let's say 34.1 kilopascal or something like that, based on the application that you are going to utilize. Okay, so it depends on, or it is also in terms of psi's. Okay, so what psi you need for your pressure sensor, that you can select. And at the same time, which are the pressure sensor that you can go ahead. So I can give you some of the companies that, like Honeywell is there, or Amphenol is also there. But I like Honeywell because it is a very high-end uh, pressure sensor device, I mean producer, and at the same time it is good. At the same time, you can go ahead with T connectivity also, because they have also a lot of pressure sensors. But Honeywell I like a lot. And you can select and put it in your bucket, so that you will be designing the circuit based on this. Okay, coming back to pin photodiode, so you can select it from Visa. So I am just putting out an idea for a designer or for a beginner, that you, here I am putting one slide. Why I am putting one slide is, let us say I want to design one pin photodiode circuit for my complete control card board application, right? So in that case, I'll come to this pin photo diode page, and I have put the part number, let us say I have put, and at the same time I have put the application circuit. So so whatever the component that we have chosen, that will be there in a record. At the same time, what are the specification that is there, and then what is the application circuit or reference design circuit that is there. And only thing that will be needed for us is, let's get into the interface. Okay, to our microcontroller GPIOs, or maybe ADCs, or wherever it is needed. So this makes our design little bit easier. Okay, coming back to, there are various applications. Wherever you see, you need to have some beep sound based on some fault condition or some alarms that need to be produced. So beep beep beep, that is there. So you can utilize your like transducers or magnetic transducers. So basically you can go ahead with CUI devices. So CUI devices is one of the best manufacturer for buzzers. Like there are very minute or small buzzers that is available with around 80 decibels capacity or more than that. Okay, uh, that is also there. So you can select a buzzer for that, and very simple circuit will be there for buzzer. Like you can just drive it through one MOSFET or one transistor, through one PWM signal. So those are specification and application circuit that you can utilize here. And at the same time, why I'm talking about like this is, you need to understand each and every page is itself a very big design for like different engineers. Okay, and there will be several engineers that may be working on a very high end application. And this way, if you have the sections in your circuits, it makes it very easy for you to understand at the same time, at a system level integration. So what is system? Like it is just a board that is there, right? But as we are going to categorize in different sections, then this all becoming one element, and all this put together going into this board itself is making a system. Okay, so system is like a different boards going to a very big system, that is also a system, or otherwise this itself is considered as a system. Okay, coming back to like USB connection or power supply options to the board, and USB protection for that. So let us say you can go ahead with Molax. Okay, or maybe Worth Electronics, or maybe Samtech. There are various manufacturers which are producing very high end or very good capability of USB connectors, which can be like USB A type, B type, or C type, or micro B type, or mini B type, any type. There are various types of USB connections that is available. And at the same time, once you do the USB connection, like you have B bus, right? And then you have D plus, D minus, and then ground is there, and all these things is there, right? So in that case, at the same time, you must take care of, like whenever you are connecting USB to the connection of your MCU card or anything, or maybe just for powering up also, you need to have an understanding that we must protect this USB device through an ESD protection. So you have to go ahead with ESD connection in these lines. Okay, and that will save your device for your EMI/MC application and all those things. On ESD diodes, you can choose it from, let's say, Worth Electronics, or maybe Nexperia is there, okay, which I like a lot. And at the same time, you can go ahead with other manufacturers as well, but Worth Electronics and Nexperia, I like them a lot. At the same time, you can go ahead with even like Murata, or maybe other manufacturers. Or even we have Little Fuse is one of the best manufacturer for ESD protection devices and all those things. The most required thing that is there in your board, which we are going to design, is having LEDs on your board. So LED can be like red color or green color or blue color, or in one package all the three color will be there, okay, or in bicolor will be there in one package. So all these kind of different variations that can be there. However, having separate LEDs for different fault indication or maybe a status indication. Let's say some fault has happened and you want to show it as a red, so you can put one red LED. So in that case, you can choose one component and keep it in your list or in your master BOM, that okay, this is the red LED that I'm going to utilize for my application. Okay, similar to that, you can have green LED, you can have amber LED or yellow LED, or maybe like blue LEDs. Okay, so those are the all LEDs range that you will be choosing from the different manufacturers. Let's say like King Bright is there, or OnLight is there, or maybe Worth Electronics is one of the best company that I always like to have my LEDs from. Okay, so all these companies, you can go ahead and choose LEDs components for your all these indication purposes. Okay, at the same time, power indication purpose, let's say your board is having 5 volt and you want it to be shown like whether 5 volt is on or not. In that case, you can connect that LED through how do you connect that? I have already given you one application. Let's say this is my 5 volt, one resistor will be there here, and then this can be connected to my ground, so that whenever 5 volt appears, it will keep on glowing on the board. Okay, so this is how it works. Coming back to push buttons, so you would have seen like a lot of push buttons are there for maybe like reset purposes, or maybe doing some interrupt functionalities. Like once you press that button, you will be liking to do some other job. Okay, or let's say you press one button and you want to appear some functionality. Let's say you want to measure temperature. Okay, so in that case, you have to push one button and then it will start measuring a temperature like that. So these are the interrupt functionalities, and you will be utilizing this kind of push buttons. Okay, so basically push buttons can be like this, okay, or it is actually like this, you would have seen. Okay, so once you press them, it gets sorted. Understood? Good. So push button also you can choose it. So you can choose it from, let's say, Panasonic is there, one of the best company, or you have like let's say Tyco is there, or Omron is there. So some several companies are there where you can go ahead. We can choose it from CNK as well. So CNK is also one of the best company for push buttons, okay, or switches. There are one more kind of switches which is always utilized in our boards, that is their dip switches. So you can also keep this in your list, that if it is required in your board design. Okay, so dip switches which will be utilized for your logic change purpose. Let's say you have 3 lines in your microcontroller and it needs to be set 000 or 010 or whatever 100. So whatever cases that you want to set it, so you can connect it through the dip switches, and these dip switches will help you to like slide the switches and make it possible for the different like logics. Okay, so you can select a lot of dip switches from your Worth Electronics. So you can select various parts, whether you need some 3 deep switches or 4 deep switches or maybe 6 deep switches, 8 deep switches. So any number of like panel that you want, you can select. So or otherwise, if you need, you can select two deep switches in 2 numbers, 3 numbers, whatever way you require. Okay. So this is what I want to tell you. Like if you are listing out all these components, it will be easy for you to design at the later stage. The most important part that comes up is power management. So let us say in your board you have like availability of let's say from outside 12 volt. Okay, so in 12 volt you can have a connector, so connector you can choose, and at the same time From 12 volt you need to change it to 5 volts. So you may select one switching regulator. That switching regulator will be giving you 5 volt. Okay, so some 12 volt application will be utilizing directly this 12 volt, and at the same time this 5 volt will be generated by a switching regulator. Let's say you need 3.3 volt as well. So from 5 volt to 3.3 volt you can go ahead with some linear regulators, okay, which will give you very clean output. So these are the part numbers that you will be needing to utilize. Now what are the parameters that we need to choose based on the specification is like what is the output voltage, okay, and at the same time what is my current rating. These are the things that we need to have, whether it can be fixed kind of regulator or like adjustable kind of regulators. All these parameters that has to be defined any requirement, and then we can like choose based on that what kind of regulator we will be using. So you have various manufacturers that is available in the market. Let us say I'll just name some two three. Let's say Texas Instrument is there, or Analog Devices is there, which is having one of the like best companies which has been acquired, like Maxim Integrated and Linear Technology and all those things. We have Renesas, we have Microchip, we have STM, and we have Renesas. So lot of we have like MPS is there. So there are various manufacturers that is there available these days, and they are producing very high end and very even low cost application uh, regulators as well. Okay, so whether do you really need a switching regulator for your application, or you can manage with your linear regulator, you have what is kind of availability is there. So this all comes under the power management, and this will be the biggest topic that will be like taking the time to design your complete board. Coming back to let's say you have various signals at the input available, and you need to send it to ADCs. Maybe you can select an external ADC, okay, and it has to be communicated, it has to be measured, all of them one by one through some SPI communication or something like that you can interface, or maybe I2C application you can interface. So all those things you can interface through the mic of your microcontroller, or also it is used in FPGA applications and all. So what happens is only one channel of ADC will be used for all these various requirements or various input voltage that you are going to measure through an ADC. So multiplexer becomes one of the best part or best option for this kind of applications. Okay, so you can choose a multiplexer as well from, let's say you have ADI, or we have Texas Instruments, or we have Nexpria. So all these companies are there which are available in the market. So TI, ADI, Nexpria is there. I am naming only few companies. It is not that I am biased to some companies. However, there are a few recommendations that I am giving you. Okay, there is no hard and fast rule that you have to get attached to these companies or something like that. However, this is bit easier to find out some of the companies, and you have always a choice to go ahead with DZ Key, okay, which is a online distributor, or Mouser. So these two distributors are there which are available online, which can give you ample amount of choices from where you can find out your particular components. Okay, at the same time let's find out let's say we have to have a requirement of buffers. Okay, so sometimes a microcontroller is not going to drive all the LEDs on its own, because its current capability is bit smaller. At the same time there are various things where you need to have a buffering requirement in the middle. So in that case you may need to have inverting buffer, like whether you are sending it to high pulse at the microcontroller, then you may require at the output to be low. So in that case you will require inverting buffers. Okay, and at the same time let's say MCU is sending you, or maybe MCU is receiving the signal. So you may need non-inverting buffer, like as it is it should go, or it should come into the microcontroller. So bidirectional buffer or unidirectional buffer, all those things you can always select. There may be a need of voltage translators or label shifter. Let's say microcontroller is not capable of supplying more than 3.3 volt logic. In that case, you need to change the output to 5 volt logic. So what will you do? You will select a voltage translator. So all these, components can be selected from, let's say, TI or ADI, or even Nexpria is there. Okay, so all these companies are producing very good amount of very cheap buffers or very high-end buffers as well. So based on your requirement, you can choose them. Coming back to the communication interface, which is the best part that is there of your board design. So whether if you need I2C communication, I mean, almost all the microcontrollers are already having I2C pins or I2C capabilities, so you can directly interface through your microcontroller pins. Same case is there with UART as well as SPI. So these are all utilized in your, let's say, I2C is used in various applications. Let's say we have uh, like photo sensors, or maybe photodiodes, or we have temperature sensors or pressure sensors. We have UART to USB connection or something like that. We have SPI, generally utilized in let us say ADC's communication or something like that. I2C is also used in your IO expanders or something. Okay, so in that case you can utilize. At the same time, there are various other functionality which comes up to, like let's say we have to have a RS-232 communication. In that case, we need to find out an RS-232 transceiver which is going to convert our signal from RS-232 to a UART, and UART will be connected to your MCU. Same case is there going to be with RS485 communication, where you need to find out an RS485 transceiver, and even one more is there which is RS422. So there also these kind of transceivers you need to identify whether you need one channel or two channel or four channel or eight channel, how many number of channels of RS232 communication you require. Those particular component you have to first decide, and then you identify them, and that's how you will be proceeding for your communication interface design as well. And since you are designing, you can keep each page for each one of the transceivers and put your application circuit, which will help you at the integration stage of the circuit design. Okay, so this is how we will be working always. So for example, if I tell you RS232 UART to USB to UART transceiver, you can utilize it from, let's say, TI. TI almost produces all kind of transceivers. So TI can give you RS232 to UART, UART to RS485, UART to RS422, even UART to USB bridge also. UART to USB bridge, you can go ahead with let us say FTTDI. Okay, and then we have Silicon Labs or Sci Labs. Okay, so these are the companies that produces UART USB bridge, and TI is there, ADI is there, and like Renesas is there. So all those companies are actually producing your RS232, RS485, and RS422 transceivers to UART. Okay, so these are the companies that can be recommended for the transceiver selection. Coming back to the most important thing that will be required on your board design or on your application circuit design is connectors. So let's say power supply connector may need little bit higher pitch, let's say 3.96 mm pitch, or maybe 5 mm pitch or something like that, or maybe 2.54 mm pitch or 2.5 mm pitch box type connector, even 2 mm pitch is there available. So all these kind of connectors that will be required, and how many pins is needed. For some programming purpose is required, some interface purpose is required. So this will be like, let's say, power supply. Okay, then we need programming purpose, then we need, let's say, interface purpose. Okay, or maybe we need some jumpers which will be just used as a, like a sorting purpose or something like that. Or these are various, like requirements that will be there for connectors, whether we have to connect some like motor drivers for three-phase motors or something like that. In that case, we have to have the understanding of how to select connectors as well. So for connectors, you can go ahead. Already I told you, like Molex is there, Semtech is there, Worth Electronics is there. Okay, so these are the various companies that is already available that we have already talked about. Let's get into, let's say you want to have a very small application of a motor driver as well on your control card, like it can drive some small fan, or let's say pump, or let's say blower. Okay, with let's say 12-volt rating or something like that, with 1 ampere capabilities. Okay, so in that case, you can go ahead with Texas Instrument, provides lot of motor drivers. At the same time, we have Rom Semiconductors. So these are the like companies which are providing you sensorless BLDC motors, and the circuit can be very easy. You just have to supply the speed through some PWM signal, or maybe they have the capability of supplying through analog voltage as well. So I have already released some of the videos for motor driver application for low like wattage. So those motor driver you can first try to find out, and then you can put your application circuit here. As I told you, like let's say the microcontroller that you had chosen had less number of IO pins, and you don't want to increase the cost of microcontroller, then there is always a possibility of having IO expander, which may be having, let's say, 16 IOs extra, or 16 IOs will be there, which can get interfaced through some I2C or SPI, and this is how it will be working and giving you an additional 16 IOs for different functionalities. So you can select IO expander from, let's say, TI or ADI or even microchip. Okay, so these are some companies that you can choose for your IO expanders. Coming back to the most important one, which is required always in your circuit, you cannot work without resistors, capacitors, inductors, or ferrite bits or fuses needed, which will be serving as a a protection circuitry for your uh, complete circuit. So all these components will be required. So based on the values and package that you will be using, so how to choose the package, because what is the power capability of the resistor that is needed, or what is the voltage rating of the capacitor or inductor, or I mean resistor is required. Those things will be taken into account while selecting the component. So I have various videos of selection process of each and every kind of components, what are the parameters that need to be taken into account, and that's how you will be designing the circuit. So hope you have now a complete understanding of what to do and how to start with your circuit design for any application that you are having in your hand. So basically you will be having the block diagram first, like what is the need, and then each one of the various peripherals you will be selecting the components for respective functionalities, and those components, each one of them will be having their respective application circuits or application circuit design, and then all those application circuits or reference designs will be clubbed together to make the complete circuit, and this complete circuit will be used as a after reviewing you can go ahead with your PCB layout design. So this was almost a rough explanation of how to design the circuit, or how to start to design a circuit for your various application. And the circuit that I have explained you is for a general purpose board that I had taken into my mind. However, we have various different ideas of how to go ahead with a specific application design. So we will be taking those sessions one by one, as and when needed. So you can always connect to us if there is a need of more deeper understanding of each and every blocks or each and every interfaces that is needed for your design, and how to generate the bill of materials, and how to work with bill of materials so that you can identify your board component suppliers very easily. Those are the things are there that has to be taken into account. So for these purposes you can always reach out to us, or you can put your comments, valuable comments in the box, and we shall be able to give you more insights of required videos that is needed, or required guidelines that will be required. So you can always give us thumbs up, or you can follow us on our WhatsApp, Facebook, or Instagram, or we have YouTube videos as well. So thank you guys.